I'd like to introduce our today's speaker. Yu-Chen Wang is a plant pathology advisor with University of California Cooperative Extension, Monterey, Santa Cruz, and San Benito counties. Today she will be speaking on lettuce production and disease management in the Salinas Valley. You can go ahead and share your slides, Yu-Chen, now.
Okay, thank you for the technical support and the introduction. Again, my name is Yu-Chen Wang. I am the plant pathology advisor of UC Cooperative Extension. I am based in Salinas. I serve the Tri-County area, including Monterey, Santa Cruz, and San Benito counties. And I will be talking about the lettuce production and disease management in Salinas Valley. So to begin with the presentation, I would like to mention that the U.S. Lettuce production is highly focusing on two states, which are the California and Arizona. So the production from California and Arizona actually account for 99% of the U.S. lettuce production. It's really based on the rotating production between these two states. Seeing here, we can see that in the summer harvest during the April to October, that is taking place in the coastal California. And let me bring my pointer. Yeah, so the summertime is in the coastal California, including the Salinas, Watsonville area, Santa Maria, Oxnard area. And in the beginning of the summer and the end of the fall, that take place in San Joaquin Valley. And during the wintertime, most of the production take place in the deserts in Imperial Valley and also in Yuma, Arizona. So this allows the U.S. to produce lettuce year-round. So the Monterey County, also known as the salad bowl of the world, it is one of the key lettuce production areas. Based on the Monterey County Farm Bureau statistics, there are over 61% of the leaf lettuce, the U.S. leaf lettuce, are producing from Monterey County. And over 56% of the head lettuce are producing from Monterey County. Besides that, Monterey County is also a key production area for other cool season vegetables such as celery, broccoli, spinach, cauliflower, and strawberries. However, behind this very high yield production is a very intensive farming system. Due to the high cost of the land rent, the growers have to grow at least 2 crops per season. And in some cases, they even have to squeeze in 3 crops per season. The commonly rotation for the 2-crop system is usually rotating between the lettuce and the broccoli or other core crops. But sometimes, some extreme case, the grower have to continue growing lettuce back and back, following lettuce and lettuce. So that continuous monocropping of lettuce can lead to a lot of lettuce disease buildup, and that challenge our production. So here we can see this is the 2025 results from our UCCE Monterey County Disease Clinic. We can see that the soil-borne pathogens here on the blue bars, they are the top key diseases here that we identify in the disease clinic. The top soil-borne disease we found there, the top one is Fusarium wilt, following with Verticillium wilt, Sclerotinia lettuce drop, and some black root rot and lettuce dieback. And for the foliar issue, INSV related issue, the Impatiens Necrotic Spot Virus related issue is the top foliar issue. And occasionally, we sometimes have damage that is caused by botrytis or bacterial leaf spot disease. So since I mentioning about the INSV, the Impatiens Necrotic Spot Virus, I'm gonna talk more about it. So actually, the first report of INSV in lettuce in Monterey County was first identified and reported back in 2006. And the outbreak, we actually start seeing the outbreak a few 10, 12 years later, starting in 2018 and continue going on 2019, 20, 21, and with the 2022, we have the highest loss from the INSV. In that year, the industry lost more than $150 million. And at that time, if you remember, you were trying to buy a sandwich. The sandwich store tell you, oh, we cannot supply lettuce on your sandwich, and that was because of the outbreak of INSV. Recently, we have some low disease incidents starting in 2023 and now, but we won't sure if the disease will continue later on. So a little bit about INSV, the Impatiens Necrotic Spot Virus. As the name Impatiens on its name, it was actually first noticed and become a very significant disease problem in greenhouse for floriculture back in 1980. The plants, they have the infection are like showing the symptoms like the spotting on the leaves, on the ornamental crops. It is a disease that is close related to the tomato spotted wilt virus, the TSWV virus, and both two viruses, they are transmitted by the western flower thrips, and they have a very wide host range. So seeing here, what's the symptoms of INSV here? This is our some INSV infected field. You can see that there are some stunted plants. The plants are infected at early stage, and further on, it's causing this kind of irregular shaped, tan to dark brown necrotic spots on the leaves, or on the older leaf, it's extensive marginal necrosis, and that wilt the odor of the leaves. So that is the symptoms on romaine. It is also causing very bad symptoms on iceberg. Similar to the romaine, it's when it's in fact early, it can kill or even or stunt the plant growth. And on the foliar, you see this kind of irregular shape of leaf spots in the color of tan to dark brown color, and also this kind of spots on the extensive spots on the leaf ribs. That is very common for the iceberg. The other thing is that sometimes, although it's looking okay on the outer leaf, but there are symptoms inside, and that is causing the loss and yield and quality damage. So INSV was found very commonly associated with other diseases, especially soil-borne pathogen diseases. And one of the most common soil-borne diseases that is associated with INSV is Pythium wilt. So Pythium wilt is a soil-borne pathogen in the oomycete group. The pathogen is the Pythium uncinulatum, and the oomycete group is water mold. It's a group of pathogen that prefer wet condition. So the symptoms of Pythium wilt seen here, including the outer leaf yellowing, the plants collapsing, and if you dig out the roots and cut the taproot open, you see this kind of root rot that is in the fine roots and also in the taproot. The Pythium wilt diseases, based on our current experience, it's highly associated with INSV. when the years there was very limited INSV or there's very minor INSV, we don't really see the Pythium wilt causing an issue. So it's in general a very weak pathogen by itself alone. So as I mentioned before, the INSV and Pythium, they are kind of having that kind of association. But at the beginning of this INSV and Pythium outbreak a few years ago, when we just started seeing it, it was a mystery. It was a mystery about what's the relationship between these two diseases, like does INSV happen first, or does Pythium wilt happening first, or if there's any relationship between those diseases. But with many years of experience, we see that some field, we know there are Pythium wilt pathogen in the soil. The inoculum is there in the soil, but when the years there's no INSV, there's no disease in that field. So we are more confident with our current understanding that is the INSV. It's triggering Pythium wilt. But here's the thing here on a special case that's collapsing romaine lettuce. The foliar, it has very minor INSV symptoms. It's tested positive for INSV, but the roots, the below ground, it has very severe root rot, which is positive for both INSV and Pythium wilt. So potentially in some cases, the INSV was able to transfer down to the roots, and with the effect of both diseases presenting and infection, the plant is taken down by the Pythium wilt and INSV, although it's only have very minor symptoms on the above ground. So that is saying that protecting these two diseases are crucial for the management of INSV and Pythium wilt. So since we are going to talk about some management, I will start with the INSV. I mentioned previously about that INSV has a very wide host range. In Salinas Valley, it is identified that several weed species and also the lettuce crops, they are the major hosts of INSV. Seeing the graph here, this is the production season of lettuce in Salinas Valley, and it's actually take place from the end of December all the way to the November next year. And with the summer and the fall, it's the peak season. There is a mandatory host-free period, the lettuce-free period for that was by the Monterey County that runs from the December 7 to December 21st every year. That was to prevent the lettuce mosaic virus spreading. So considering that kind of period, there's a potential that if we go managing the INSV host when there's no lettuce, we manage other weed. They are presenting consisting the virus during the lettuce-free period all the way to the beginning of the season, the springtime. There's that potential we can do a very good job on the INSV weed management because the virus level is very low in the system, and not until the end of fall is getting higher. So researchers, including Daniel Hasegawa and Richard Smith, they have identified the top 10 non-lettuce INSV hosts in Salinas Valley. That is including these weed species here. For example, the little mallow, malva, the lump squirter weed, the surface spurs, mare's-tail, and the annual salt thistle, nettle leaf goosefoot, the field bindweeds, the hairy fleabane, the burning nettle, and the purslane. We have seen the how those weedy area becoming the INSV reservoir, especially when the springtime the disease is low and they are moving from the weedy area to the new planting of lettuce. So there was one very weedy area, and after the grower have mowed the weed, we start seeing that the gradient of INSV in the next lettuce crop. So the virus are traveling with the thrips over to the next to the adjacent lettuce crop and causing damage. There's often comes out with a question regarding other plant species. They are commonly found in Salinas Valley, whether they are the host for INSV, including the ice plants, the strawberry and the artichoke. Based on our current research, those three crops and those three species, they are just habitat for thrips, but not INSV. So because of the structure and the structure of the flower buds, and also the thrips are feeding on the pollens, we see a lot of time the western flower thrips, they are feeding and they are living on those fields or those habitat. But again, good news, they are just the habitat for the western flower thrips, but they won't be able to infect or transmit INSV. Just not something, there could be feeding damage, like browsing, that could be caused by western flower thrips on strawberry fruits. So that is the first management we have to consider. And the next, we all know that the virus is transmitted by the vector, the western flower thrips. So the early scouting and the sprays could be helpful. And further on, for the growers' consideration, we have seen that the worst heat areas continue become the worst heat area for the future season. So if the grower have experienced some worst heat areas experience, they can avoid planting lettuce again in those worst heat area, especially focus on the fall season planting that we know the INSV level is the highest in our system. And there are also some tolerant and or resistant varieties available. But if those seeds, those resistant variety seeds are limited, you may want to save them for the fall season when the INSV level is the highest, when the risk is higher. So we have been doing this kind of variety evaluation in the field for the tolerance of INSV and Pythium wilt since 2022, working with researchers including Richard Smith, Kelly Richardson, and JP. We have screened many variety, over 120 entries, have over 10 seed company participated in the evaluation, and those results are posted on the Salinas Valley Agriculture blog or on our UCCE Monterey County website. So if you want to see the results, you can go search on those two sites or reach out to me. And moving forward, I would like to talk about lettuce soil-borne pathogens. As I show you in the very beginning, currently lettuce Fusarium wilt is the top soil-borne pathogen we see in Salinas Valley. The lettuce Fusarium wilt is a lettuce vesicular disease. The field or the plants infected by the lettuce Fusarium wilt have the symptoms of yellowing, stunting, or the death of the seedlings. You can see this is a field that's a lot of seedlings, they are already die from the disease, and the symptoms can be seen as early as the thinning stage. And if you cut the taproot open, you can see the reddish and brown discoloration in the vascular system. It is in the taproot or in the crown area. So that is the so that is caused by the soil-borne fungus, Fusarium oxysporum for most species Latuke. So this pathogen actually can grow inside the vascular system in the xylem area and blocking the water transporting system. So the plants eventually cannot absorb water from the soil and die from the disease. So vegetable Fusarium wilt is very common. It's also there are also other vegetable Fusarium wilts. So here at the left, you can see that this is the tomato Fusarium wilt. Sometimes you can see the symptoms starting from only one branch wilting, and the other side is not affected. But that is because of the water conducting system in the roots is being blocked and being affected. But eventually, when the disease is more advanced, the whole plants will collapse and wilt. And at your right-hand side, this is the watermelon Fusarium wilt. In the Salinas Valley, we also commonly see is the celery Fusarium wilt, or we sometimes call that celery Fusarium yellow. The symptoms, we don't really see the celery plants wilting, but it's this kind of yellowing on the outer leaves, and the plants is in a very bad and not vigorous condition, and seeing the root discoloration is also on the crown and taproot area. And on your right-hand side, this is the pea Fusarium wilt, and you can see the right side of the plants is being affected. The leaves are turning yellow, and also the taproot, this kind of discoloration that is because of the Fusarium wilt is blocking and reproduce in the water conducting system and cause the root damage. So I mentioned about lots of vegetable Fusarium wilts, and we know that there are many vegetable crops that could be suffered from Fusarium wilt. Here's the thing. The vegetable Fusarium wilts, they are mostly crop specific. So for example, here, the lettuce Fusarium wilt is caused by the Fusarium wilt oxysporum for most species Latuke. It is different from the strawberry Fusarium wilt, which is caused by the Fusarium oxysporum for most species Fragaria. And it's different from the pea Fusarium wilt, and it's also different from the spinach Fusarium wilt, and it's also different from the celery Fusarium wilt, seeing that they all have different species name following by the formal species term. So this is saying that it will be relatively straightforward for our crop rotation consideration. If we know there is a field having lettuce Fusarium wilt, having the Fusarium oxysporum for most species Latuke, it should be safe to plant other crop like strawberry, like pea, like spinach, or like celery. But recently, we have seen that that was the general understanding, but recently we have seen that the cross crop infection in the same family situation that is happened recently in the cilantro case. It is the same family with the celery. The cilantro Fusarium can caused by the Fusarium oxysporum for most species, cori and dairy, but also the FOA, the celery Fusarium race 4. So that would be the cilantro grower have to put into consideration. Not only the celery need to be considered, but also if the field have the celery raised for history, the grower may want to avoid planting cilantro in that land. Using tolerant variety is one of the key for disease management since 2023 until now. With Alex, Chris, and Stephanie, we have been doing the variety evaluation in the field to test their performance of tolerance to Fusarium wilt. There are currently two race. One is race 1 of Fusarium wilt, and the other is a CR4 variant Fusarium pathogen. The two kind of race in existing in the Salinas Valley and the Central Coast, California. So that would be something to put into consideration if some variety they are supposed to perform tolerant, but ended up performing not tolerant. That might be due to the race type you have on your field. Over the past few years and continue in the upcoming 2026, we will continue screening for more variety, some new variety or some older variety to prove its tolerance ability in the field. And again, we are including all the seed companies to collaborate, and the results will be on our Salinas Valley Agriculture blog and on our Monterey County website. So we typically understand that the iceberg is more susceptible to the Fusarium wilt. But in our recent field evaluation, we do see some new romaine variety they could be susceptible. So it's the symptoms of romaine Fusarium wilt is very different from the iceberg Fusarium wilt. It's the plants getting stunted. The plants may die in the early stage. So it's very different. And we can see here two variety planting side by side. One is the resistant, the tolerant one, and here next to it is a susceptible variety. So here's the question. So if planting a tolerant variety could be a good way to manage Fusarium wilt, can I just continue planting the tolerant variety without rotating it out to other crop? So a quick answer is no. Back in 2014, researcher including Scott, Roberts, and Gordon, they did this research studying the pathogen colonies in the roots of the tolerant romaine, of the susceptible iceberg, and the broccoli, cauliflower, and spinach. We can see that in the tolerant romaine, indeed, it has lower pathogen colony than the susceptible, but it has a lot higher pathogen colonies in the roots than the broccoli, than the cauliflower, and the spinach. So it is, although it's a better choice, the tolerant romaine is a better choice than the susceptible iceberg. It can still maintain certain level of pathogen colony in the soil. How about new technology in managing Fusarium wilt? In 2025, we work with Steve Fenimore and Alex Punman investigating how the steam soil disinfestation can manage the Fusarium wilt. So this is the steamer that is passing through the field and injecting steam into the soil before planting. And in that year, we tested two steam temperature, like 158 and 194, and also control to test which temperature will be able and will provide the efficacy for managing Fusarium wilt. And the results show up that yes, indeed, when the steam is at the higher temperature, 194°F, we do have higher marketable iceberg percentage than the control, and also a little bit lower temperature, like 158, is also showing better efficacy than the control. But the current issue is that the steamer move very slow in the field. So the researchers are still working on it to scale up the efficiency of the steamer. That would be the next step the researcher is moving forward to do. So in summary here, about the lattice Fusarium wilt, we have seen that's causing huge loss in the whole Salinas Valley. Historically, we used to know it's a South County issue, but right now it's not. It's the whole Salinas Valley issue, even in the North County, in the Salinas area, or in the Hollister area, or in Watsonville area, we have seen huge loss caused by the lattice Fusarium wilt. Secondly, is the use of tolerant variety can be effective for disease management. There are the race 1 and the CR4 variant. They both presented in Salinas Valley. So that would be the consideration of which tolerant variety to use. Steam treatment could be effective, but researchers are working to scale up to making it more efficient. And there are some research currently going on, study other efficacy like fungicide, biofungicides. It is ongoing. Okay, speaking about soil-borne pathogen, we have other soil-borne pathogen challenge. Another disease called lattice verticillium wilt. It is also a lattice vascular disease. It's caused by the soil-borne fungus Verticillium dahliae, and symptoms are like the yellowing and wilting and collapsing of the outer leaf, and that usually happen near harvest. And if you dig out the roots and cut the tap root open, you will see this green, brown, and black discolor streaks. That is the pathogen damaging the vascular system. So unlike the Fusarium wilt, the Verticillium wilt, it has a very wide host range. So here are the hosts and the susceptible crop. That is including the lettuce, the spinach, cabbage, cauliflower, strawberry, artichoke, chickpeas, fava beans, and some of the cucurbits and solanaceae crop, and also the mint. The non-host option will be the Apiaceae family, including the celery, cilantro, parsley, and the brassica family, including the broccoli, and also the pea, the bean, the grass cover crop, the rye, the wheat, and also the corn. They are currently known as non-host. Symptoms of cauliflower verticillium wilt, including this kind of black discoloration on the outer vascular system, and on the above ground, you can see the whole plants collapsing. So in general, the management of verticillium wilt rely on practice good crop rotation, and there are some research show that broccoli could potentially suppress the verticillium wilt pathogen, and also there are also resistant and tolerant lettuce variety available. And lastly, because it's a soil-borne pathogen, you may want to practice good sanitation, especially washing equipment that could prevent the movement of the infected soil. Or if you know there's a field that has Fusarium, that has verticillium wilt, you do your land work on the cleaner part of the field first before moving to the field you know there is a pathogen. Following moving forward is another soil-borne pathogen. It's the Sclerotinia lettuce drop, also known as the white mold. It's caused by the soil-borne fungus Sclerotinia minor, and here we can see the symptoms of the disease, including this kind of brown, soft decay of the crown tissue, and also the base of the plants. And because of the infection there, the plants will eventually wilt and collapse. And if you take the plants up, if you dig out the plants, you won't be able to dig up the whole root because the damage is happening at the crown level. But a lot of time you can see this white mycelium and also the black hard structure, the sclerotinia. That is the surviving structure of the pathogen. So because of the fact that the sclerotinia pathogen tend to persist at the surface of the soil, the deep inversion plowing may be helpful to manage the sclerotinia lettuce drop disease. And on the other hand, it's preferred the wet condition. So you may want to avoid overly wet soil and to ensure good drainage. Other known crop hosts of sclerotinia are endive, escarole, tomato, pepper, fennel, celery, cauliflower, and beans. Those are something we need to avoid planting. So some chemical have efficacy on managing sclerotinia lettuce drop, but they have to use preventively. Usually we use it at thinning. These are the chemical, the AI that has proved having some efficacy in managing the sclerotinia lettuce drop. Those are the AI including improdione, the cyprodinol plus fludiacinol premix products, the dichlorine products, the boscalid products, and the fludiacinate products. There are some preliminary research proving the efficacy of this AI. Okay, the very last soil-borne pathogen I want to mention about here is the lettuce black root rot. It's caused by the soil-borne fungus Berkeliomycetes basicola, which was formerly known as Thelaviopsis basicola. It's relatively new, so I want to make sure you guys are aware of this. It was actually first reported back in 2008. It has also have a very wide host range, and it can cause the black root rot symptoms on ornamental plants and other vegetables such as carrots, pea, table beets, or tomato. Cold crop. Currently, we understand that cold crop is non-host for this black root rot pathogen. So although it's a relatively minor disease, it did occur occasionally. So here is the field symptoms of the lettuce black root rot, including this kind of spotty, stunted plant in the field. So that could lead to the uneven growth of the plants. And the thing how it looked like stunted and spotty and uneven growth, a lot of time can get confused about maybe it's because of the lack of fertilizer. But it is not. It is a plant pathogen. It is a soil-borne pathogen. So applying more fertilizer won't fix the problem. Symptoms of the black root rot in the roots, including this kind of small black to brown color bending and lesion on the leaves. And because of the infection, the bending is fragile. Sometimes the roots will break at the point where the bending are and leading this kind of root rot symptoms at the very end of the root tips. And that could occur on many feeder roots and the secondary roots and affect the water absorbing ability of the roots. So very quick field diagnosis method I would like to share here. You basically just prepare one bucket with a jar of water, dig out the plants you suspect there could be black root rot, and rinse off the soil gently in the water, and ended up evaluating if there's bending on the roots and how is the root looking. So that will be a quick field diagnosis for the black root rot disease. Since soil-borne pathogens are a huge issue in our in our production, I would like to summarize with a few general management strategy, and I think you guys are familiar with that. But just here a quick reminder of a few general management strategy we can use for soil-borne pathogens. The first one is record keeping. So those soil-borne pathogens, they usually have those kind of surviving structure allow the pathogen to survive in the soil for long time, sometimes more than 3 years, sometimes more than 5 years. So it would be good if you can keep the record, especially focusing on what soil-borne disease are there, which crop, which variety, and where the disease are. If you have a very large acreage field, you may consider mapping out the disease distributions, because it might be just localized in certain area, and you can use the cleaner area for the non-tolerant variety, which might have better yield production. And third, make sure you also document what time of the year, what's the weather, the disease is happening, because that will be also a crucial information for the disease occurrence. Secondly, I would like to mention is that accurate diagnostic can guide effective disease management. Here I show 4 root symptoms of lettuce. Here they all have some kind of fascicular or crown discoloration, but they are caused by 4 different kinds of issue, and only 3 of them are pathogenic, and 1 is an abiotic issue, the ammonium toxicity. So without proper or accurate diagnosis, it could be very challenging to see what's going on actually there. And once if there are diagnostics, making sure proper management is applied. For example, the fungicide used for sclerotinia, the white mold, it may not work for Pythium and Phytophthora. Those disease, they are oomycetes. They are another group of fungi. So making sure you apply the proper fungicide or the proper treatment for the disease. Third, I mentioned several times about crop rotation, which contributes to management by providing a host-free period. That's the pest, the disease, they don't have food to survive. But you want to consider what kind of pathogen are there, so you can know what crop you want to rotate it out, because some of the soil-borne pathogen, they may have a very wide range of hosts than others. Usually, generally, broccoli or small grain cover crop, they are usually good options. And using tolerant variety could be helpful. But again, I want to remind you, they may maintain still certain level of pathogen level in the soil. So eventually you want to rotate out lettuce completely. Another thing I want to mention is the time of the planting. We usually know we have a drought, we have a very dry spring, but in some season, a wet spring year, we do see the lettuce anthracnose. We do see very bad Pythium disease or Phytophthora disease. Those are the disease prefer the wet condition. So if you see the forecast having a wet spring, you may want to focusing on the management and making preventative treatment for the lettuce anthracnose, the Pythium, and Phytophthora. So Fusarium wilt is known that prefer warmer condition, and right now we know that the planting window can help, and especially the first few weeks of planting is crucial for the disease infection. So planting when the soil temperature is cooler could also be a strategy to managing Fusarium wilt, since it's a pathogen that prefer high temperature. So planting at sometime it's cooler might be helpful. Irrigation management, prevent the overwatered condition, prevent the saturated soil will be helpful. And lastly, the prevention. So I mentioned about the soil-borne pathogen have surviving structure that allow it to survive in the soil. So that means once the pathogen have been introduced to the field, they are very difficult to remove. So making sure if you know there is a disease there in certain field, you don't work you schedule your working schedule, your land prepping schedule to work on that land later. And if you once you finish working on that land, you can washing off the soil from the equipment, and that will be very helpful to prevent the movement of that infested soil. So that's all I have today, and I would like to thank you for your attention. And I am more than happy to assist you with you. If you have any information, please reach out to me. And I think we have a couple minutes to answer some questions from you guys.
Thank you very much, Yu-Chen. Yes, we do have few questions. I will try to choose some that may be easier to respond in short time that we have left. Are there any California native plants that help crops resist INSV, ISVN?
That is a very good question. Currently, researchers like Daniel Hasegawa is investigating that concept because, like, if there are some other plants to compete out the thrips going to the lettuce crop, that could be a very good strategy to preventing the thrips going to lettuce to spread out the virus. But that is a research currently ongoing. I don't have much to share, but that is really a good point.
Okay. At the first part of your presentation, you mentioned the lettuce-free or crop-free period at the end of the year. When you say the lettuce-free, does it include planted seeds?
No, sorry. That means no lettuce in the above ground. So it's fine. The seed is in the land, but no any lettuce on the above ground. Thank you for that question.
All right. Any thoughts about incidence of these diseases that you talked about in lettuce production in hydroponics?
We have a very limited production of hydroponic in this area, so I wouldn't be able to comment on that. But thinking about the hydroponic system using more water and a wetter condition, I can think about some pathogen that prefer the condition of wet conditions such as Pythium, right? Such as Phytophthora. So that would be some issue you may want to pay attention on.
Then you also mentioned that several weeds are host plants of INSV. Do they produce similar symptoms as the lettuce plants affected by INSV?
Thank you for that question. The weed infected by INSV could be asymptomatic. It could be no symptoms. So right now, we advise the grower during the lettuce-free period and also the springtime, we're focusing on those older weeds. Those could potentially be carrying over from the end of the season, from the fall, where the INSV, where the thrips are traveling to, and eventually hosting the virus. So right now, the springtime and the host-free period, we're focusing on managing those older weed, although they are asymptomatically.
Thank you very much. Thank you, Yu-Chen, very much for presenting today, and thanks everybody for attending.